Standard 7th, Subject Maths. Chapter 5, Operations on Rational Numbers. Today, let us learn how to solve practice set 24. Let's learn decimal form of rational numbers. Now that you know what are rational numbers, we are going one step ahead and we are going to learn the decimal form of rational numbers. You already know about decimal numbers. So now look at the example. Write the rational number 7 upon 4 in decimal form. Now 7 we will divide by 4 and we will write the answer in decimal form. How do we do that? Okay, let's look at the division which is shown here. 7 divided by 4. There is nothing ahead of 7, so we put a decimal point and write as many zeros as required to solve this particular rational number. Okay, so 4 ones are 4. Subtracting 4 from 7, you get 3. Okay, the 0 which is there after decimal point comes down, and at the same time you're going to write the decimal point in the quotient also. Okay, so now you have got 30. 4 sevens is 28. 2 is the remainder. Another 0 comes down. Okay, 4 5s are 20 and now the remainder is 0. So what we have done here, we have carried out the normal division. Only after we divide 7 by 4, there is a decimal point. So after the 1 in the question, we take a decimal point. In this way, you are going to write the decimal form of rational numbers. So 7 is equal to 7.0, which is also equal to 7 point as many zeros. Any number of zeros can be added after the fractional part. So 1 is the question and 3 the remainder after dividing 7 by 4. So see the instructions. Now we place a decimal point after the integer 1 in the quotient, writing the 0 from the dividend after the remainder 3. We divide 30 by 4. As the question we get now is fractional, we write 7 after the decimal point. Again we bring down the next 0 from the dividend and complete the division. So this is what I explained to you. Carry out normal division, only take care of the decimal point. Okay, once you start dividing the number which is after decimal point, that time you have to put decimal point in the quotient also. So it's quite simple. Another example. Write 2 1 upon 5 in decimal form. Here you have a mixed number. So first step you will convert it into a improper fraction. So 2 5s are 10 plus 1 11. 11 upon 5. So now 11 upon 5 is the fraction that you have got. We shall find the decimal form of 2 1 upon 5 is equal to 11 upon 5 in 3 different ways. But here 2 methods are shown which are quite simple, and that's why I've chosen these 2 different methods. So let's see the first method. Find the decimal form of 1 upon 5. Now, to find the decimal form of 11 upon 5, not 1 upon 5, 11 upon 5, we will divide 11 by 5. So, what are we doing here? 5 2s are 10. So 11 we have operated by taking 5 2s are 10 and remainder is 1. Now you can see a decimal point. So in the quotient also put a decimal point and then bring the 0 down. Again 5 2s are 10 and now remainder is 0. So 2.2 is your answer. This is one method by dividing normally and taking the decimal point wherever it is required. Another method is convert the fraction with the denominator 10, 100, 1000 that you have done before in the previous chapter. So 11 twos are 10, 11 twos are 22 and 5 twos are 10. You got denominator 10. So since 1 0 is there in denominator, decimal point will come before 1 place in numerator. 2.2 is your answer. But in this practice set, we are going to follow the first method here, which is by division method. Okay. So like this, we can find the decimal form of a rational number. Another example. Write the rational number minus 5 upon 8 in decimal form. Now rational numbers, there are also negative signs involved. The decimal form of 5 upon 8 obtained by division is 0.625. Answer is given here. So if it is minus 5 upon 8, answer will also come minus. So the minus 5 upon 8 is equal to minus 0.625. So you have to keep this in mind. Negative fraction, then you have to write the answer also negative. In all the above examples, we have obtained 0 as a remainder. This type of decimal form of a rational number is called the terminating decimal form. Terminating decimal form means you will get your remainder 0. Okay. Now let's have a look at these examples. Let us see how the decimal form of some rational numbers is different. Write the number 5 upon 3 in decimal form. So simple, we start. We write 5 as the dividend and 3 as divisor and we divide. 3 ones are 3, remainder 2. Now after 5, we put a decimal point and write zeros to carry out the division further. Since the point is come, so we take in the quotient also one decimal point. And then we operate further. 3 6 are 18. So from 20, 18 is subtracted. Again 2 comes down. Again get a 0 down. Again 3 6 are 18. 2 is the remainder. So you will see that 2 is the remainder every time now. That means 1.666 it will go on. 5 upon 3 is equal to 1.666 so on. Therefore 5 upon 3 is written as equal to 1.6 is written only one time and on 6 you have to put a point showing that it is repeated. So whenever you write the answer in this form 1.6 and on top of 6 one dot, it indicates that the number 6 is repeated in the quotient. Okay, let's have a look at another example. Write the number 2 upon 11 in decimal form. Now 2 divided by 11, we cannot divide 2 by 11, so we take a 0 first. 11 zeros are 0, 2 comes down. Now there is a decimal point, so after 0 in the quotient, we put a decimal point and we carry on further. 11 ones are 11, 9 is the remainder, 0 comes down. 11 8s are 88, 2 comes down. And you take a 0, you get 20. Now you will see this 20 we have got already in the first step. So 20 will repeat. So we will take 11 ones are 11. Again 11 8s are 88. 11 ones are 11. 11 8s. So 1 8 1 8 will keep on repeating in the quotient. So when two different numbers are repeating, more than one numbers are repeating in the quotient, you put a bar on top. Okay, so you will have to put 0.18 and the bar on top of it means the horizontal line above the digits will indicate that those digits are repeating in the quotient. So 2 upon 11 is equal to 0.181818 and so on. 18 will keep on repeating. So we need not write 18 every time. How you will write it? Therefore 2 upon 11 is equal to 0.18 and horizontal line above 18 says that 18 is repeating again and again. So if a single number is repeating, you put a dot on top, a point, and if more than one numbers repeat in the same sequence, then you will put a horizontal line on top. So this way you can complete your working. Let's see two more examples. Find the decimal form of 2 1 upon 3. Now 2 1 upon 3 is equal to 7 upon 3. 2 3s are 6 plus 1 7. 7 upon 3. Divide and you get 2.33. Now 3 will keep on repeating. Every time you will get one remainder. You take a 0, 3 3 is a 9, again one remainder. So in the answer we write 2 1 upon 3 is equal to 2.3, and on top of it you will put a decimal point or just a point on top of 3, which will say that 3 is repeating in the quotient. Okay. See the fourth example. Work out the decimal form of 5 upon 6. Now 5 divided by 6. Okay. So now here 6 zeros are 0. Okay. First you take. Then 0 point, because there is no other number. So 6 8s are 48. Then remainder 2. Then you take a 0, because now you have taken a decimal point, you can keep on adding zeros. Okay. So 6 8s are 48 is over. Now 6 3s are 18. Again 2 0 we got. 6 3s are 18. Again remainder is 2. So you will keep on adding zeros to 2 and you will keep on getting 20, and 6 3s are 18 every time. So we did not solve further. We can simply write 5 upon 6 is equal to 0.833, and once the number is repeating, you simply have to write 5 upon 6 is equal to 0.83, and above 3 you will put a point saying that 3 is going to be repeated now onwards. So in all the above examples, the division does not come to an end. Okay. That means we are not getting the remainder 0. Like previously we got the denominator 0, and what did we call them? Terminating decimal form. Now here there are remainders left over. Here a single digit or a group of digits occur repeatedly on the right of the decimal point. This type of decimal form of a rational number is called a recurring decimal form. What it is called? Recurring decimal form. And when you get 0 as a remainder, it's called terminating decimal form. Means the division is terminated. If in a decimal fraction, a single digit occurs repeatedly on the right of the decimal point, we put a point. Remember this. Above it, as shown here. 2 1 upon 3 is equal to 2.33. 3 is repeating. So what you write? Equals to 2.3, and on top of 3 1 dot. And if a group of digits occurs repeatedly, we show it with a horizontal line above the digits. Thus 2 upon 11 is equal to 0.1818 is equal to, how we write? 0.18, and on top horizontal line above 18 only, saying that 18 is repeated again and again. And 5 upon 6 is equal to 0.83 on top of 3 dot, because only 3 is repeating. So if a single digit starts repeating, you have to put a dot. If more than one digits are repeating, then those numbers you have to write, and on the top of it you have to put a horizontal line. So that's all. Now what have you learned from this? Now I know some rationals have a terminating decimal form, that is their remainders are 0, while some have a recurring decimal form. Recurring means the remainders are not 0, and sometimes the quotient you will see digits repeating, which are written as a point on top of it if it's a single digit repeating, and if more than one digits are repeating, you put a horizontal line. So with practice you will be able to do this in a very simple way. So now we begin our practice set 24. Write the following rational numbers in decimal form. You are given 7 questions which you have to write in decimal form. So let's see how we can divide and do this. Okay. So the first sum, 13 upon 4. Now 13 upon 4 we divide. So we need to divide. So 13, put the point first only and take 2 zeros and keep. If you require more, we can take a number of multiple zeros here. So 13.00, we have written the dividend, divide by 4. Okay. Now we start the division. 4 3s are 12. remains 1. Remainder is 1. Now after 13 is completed, there is a decimal point. So in quotient also, after 3 put a decimal point. Okay. So as soon as the left hand side of decimal point, the integer part is worked out, you have to put a decimal point in the quotient also. So 4 3s are 12. Over, working is over, you got remainder 1. Now before you take the next digit in the question, in the dividend, you have to put a decimal point in the quotient. 3 point. Now you start. Take a 0 down. 4 2s are 8. From 10 you subtract 8, you get 2. Now bring another 0 down. 4 5s are 20. And subtracting 20 from 20, you get remainder 0. So which type of decimal rational number is this? This is terminating decimal form where the remainder is 0. So your final answer is 13 upon 4 is equal to 3.25. Okay, very simple. We just divided 13 by 4, and to carry out the complete division we wrote 13 as 13.00 and worked out the sum. In the question we put a decimal point just after 3. That means just after solving the number 13. Okay. Let's see second sum now. Minus 7 upon 8 is equal to, now we don't want minus sign while dividing, so we keep minus 7 upon 8 as minus 1 into 7 upon 8. Minus 1 we keep separately so that we can afterwards put the value what we get upon 7 upon 8 as the answer, and we can put the minus sign to the answer later. So let's work out now 7 upon 8. 7 has to be divided by 8. We cannot divide 7 by 8, so we take a 0 first. 8 zeros are 0. 7 comes down. Now you are going to take a 0 down along with 7. So before taking that 0 down, you can see a decimal point in the dividend. So in the quotient also, next to 0 you have to put a point, decimal point. Now you are ready to do the second step. 8 8s are 64. Remainder 6. Bring a 0 down. 8 7s are 56. Remainder 4. Bring another 0 down. 8 5s are 40. Remainder 0. So we have got a final answer as 0.875. So this too is a terminating decimal form of rational number. Okay. Now since we had divided 7 by 8, we have to multiply 0.875, which is our answer, by minus 1 to get the negative sign back to the answer. So let's see. Minus 7 upon 8 is equal to, we have written on top there, minus 1 into 0.875. So minus 1 into 0.875 will be minus 0.875. If you don't want to show this working, you can write the answer directly as minus 7 upon 8 is equal to minus 0.875. Don't forget to give the minus sign to the final answer, since the question bears the negative sign. Okay. So this way we have completed second sum. Let's move on to third one. We have a mixed number here, 7 3 upon 5. Now first we convert it. 7 5s are 35. 35 plus 3 38. 38 upon 5 is the fraction that we have got. Now we will divide 38 by 5. 5 7s are 35. Remainder 3. Now since we need to carry out division further, we take a point next to 38 and we write 0 there. Since a point is come and 38 is already worked, so in quotient also you will take a point. 5 6 are 30. 30 minus 30, 0. So this is again a decimal form of a rational number in the form of terminating decimal form, where the answer is 0. Remainder is 0, sorry. The remainder is 0 and your answer is 7.6. So 7 3 upon 5 is equal to 7.6. So simple division we have carried out. Just don't forget to take the decimal point in the appropriate place. In the dividend you see the decimal point after 38. So as soon as you work out the division of 38, take a decimal point in the quotient before you start the further division, where you take a 0 next to the dividend after decimal point. Okay, so it's very simple. With practice you will find it very easy and interesting too. Fourth sum, 5 upon 12. Now 5 we have to divide by 12. Now 5 cannot be divided by 12, so we take a point and we write zeros. You can start with 2 zeros and afterwards you will realize you need more. So you can add on the zeros anytime, not a problem in the dividend. So 12 zeros are 0 we start with. 5 comes down. Now since 5 is operated, we will take a decimal point in the quotient next to 0. 0 point, because after 5 is a point. So 0 also after 0 in the quotient on top, you will take a point. Now your 2 zeros you must have written, or 3 or 4, that you will depends upon as we solve. So let's start with the second step. 12 fours are 48, because 50 is the remainder. Now we need to solve the closest one. 12 fours is 48. Remainder is 2. Bring one more 0 down. 12 ones are 12. We can't take 12 twos are 24. So 12 ones are 12. From 20 we subtract 12, we get 8. Bring one more 0. If you have not written extra zeros in the dividend, you can add now. So take one more 0 in dividend and bring it down. So 12 6 are 72. Subtracting 72 from 80, you get 8. 8. Now we need one more 0 to solve further. So keep on adding zeros till you reach a number which repeats. Okay. So we added one more 0. Now 12 6 are 72. Remainder 8. You will observe that 8 is coming repeatedly as a remainder now. Means 12 6 are 6 is repeating in the quotient. So we can stop here. And how will you write your answer now? I had shown you in the examples. Yes, your answer will be 5 upon 12 is equal to 0.41. Will we write 6666 continuously? No. On top of 6 you will put a point saying that it is repeating in the quotient. So let's see. 5 upon 12 is equal to 0.416 and above 6 a dot. We are not putting horizontal line here because only a single digit is repeating now, 6, not 416. If you would see 416, 416, 416 repeating, then we would put a horizontal line on top. But only 6 is repeating now. So we put a dot above 6. So this is which type of rational number in decimal form? This type of decimal form of a rational number is called a recurring decimal form. Okay. Previously, the first 3 sums you got terminating decimal form. The fourth sum shows recurring decimal form of a rational number. Okay. Let's go to fifth one. 22 upon 7. This is also the value of pi. Okay, you will learn that later. So 22 upon 7, we have to divide 22 by 7. 7 3s are 21. You can start easily. Remainder is 1. When there is a remainder and you need to solve further, what do? We take a point and we keep on adding zeros till we come to a conclusion that the number is repeating or something like that. So first you can start with 1 0. Now since the decimal point is come, we will put a decimal point in a quotient after 3 on top. And then we will take a 0 down. So 7 ones are 7, 10. From 10 we subtract 7, you get remainder 3. Now 3 we have to solve, so we take a 0 down. On top you will mention zeros next to 22 point as many zeros as you require, you can keep on adding them, because after decimal point we can add as many zeros as we want. Okay, so 0 comes down, 7 4s are 28, 2 is the remainder, another 0 comes down, 7 2s are 14, 6 is the remainder, another 0 bring down. Now 7 8s are 56, another 4 is the remainder, another 0 you bring down. 7 5s are 35, 5 is the remainder, one more 0 you bring down. 7 7s are 49. Till now you will see none of the remainders are repeated. But now when you took 7 7s are 49, the remainder is 1. 50 minus 49, remainder 1. And after 3 point in the quotient on top you have got 1. Means again the sequence is going to be repeated. 1 4 2 8 5 7. Okay, that means this is a recurring form of a decimal form of rational number. And how you will write the answer now? Since 1 is repeated, not that 1 only will keep on coming. After 1 what you got? See in the question you got 4, then you got 2, then you got 8, then you got 5, when you got 7, then 1. Means this sequence is going to be repeated. So we will put dot or a horizontal line. Think about it. Yes, we will have to put a horizontal line above all the numbers that you see on top, because 1 is come which was already there before in the question. And now after 1 you will get, see, suppose you take a 0 and 7 1s are 7. Then your remainder will be 3. 7 4s are 28. Same sequence will repeat. So your answer will be 22 upon 7 is equal to 3.142857 and horizontal line on top, which shows that all these digits are repeated now in a sequence. Okay, let's solve question number 6 now. 4 upon 3. 4 divided by 3, 3 1s are 3, simple, got remainder 1. Now 1 cannot be left, so we need to take a point after 4 and write zeros. So point in the quotient after 1 also we will put at the same time. Now go further. 4 3s are 9, remainder 1. 0 comes down, 4 3s are 9, remainder 1. Every time we are getting remainder 1. And every time we are getting the quotient as 3 now. That means 3 is repeating itself. So what your answer will be? 4 upon 3 is equal to 1.3. Will you write 3? No. 1.3 dot on top, because 3 is a single digit which is repeating. And when a single digit repeats, we put a dot on top of that number or of that digit. Okay. So what type of rational number is it? It is called a recurring decimal form of a rational number, because the remainder is not 0 and you can see the number 3 is repeating itself. So 4 upon 3 is equal to 1.3, a dot on top of 3. Okay, this is very simple once you practice. Last, 7th sum, 7 upon 9. So we will divide 7 by 9, we cannot. So take a 0 first, 9 zeros are 0. 7 comes down. Now we can take a point after 7 to add zeros. Since a point is come, in the quotient on top also after 0 put a point. Now 70 is what we got after getting taking a 0 down. So 9 7s are 63 is the closest. So 9 7s are 63, we write down, minus from 70 you get 7 again down. So another 0 you bring down. 9 7s are 63, again 7 you got. That means the remainder is going to be always 7 now. Okay, and 9 7s are 63 is what you're going to operate it. So instead of going on operating it, we are going to write down our answer as 7 upon 9 is equal to 0.7, and what you will put, a horizontal line or a dot? Yes, you guessed it right now. You got it. Your answer will be 7 upon 9 is equal to 0.7, a dot on top of 7, saying that 7 is repeating itself. Okay, this is how we have solved our practice set number 24. Do solve it in your book. Okay, stay safe, keep learning, and thank you, students.